Hello friends, welcome back to the class. Today we are going to discuss about we are going to start the new chapter organic photochemistry. Friends, this is Rambabu, your organic chemistry faculty. So here in MSc organic chemistry second semester, the paper 2 organic chemistry has 4 chapters: reaction mechanism 2, pericyclic reactions, organic photochemistry, and reaction intermediates and rearrangement reactions. So here today's topic is photochemistry. So what is photochemistry? So friends, the definition of photochemistry, obviously we are discussing about chemistry. It is a branch of chemistry. The photochemistry is a branch of chemistry. Here in this chapter, so whatever the chemical molecule is there, that chemical molecule absorbs the light and it will undergo some changes, that may be chemical change or physical change. Then such a type of study is called photochemistry. So what is happening? So you are taking a molecule, this molecule on irradiation with light. Now this will undergo excitation. So excitation always takes place in electronic levels here, right? Because we are going to use UV visible radiation in organic photochemistry, and finally we are going to get the product are obtained. So the products are obtained with chemical change or physical change. So the complete study is called photochemistry. So what is a photoprocess or photochemical reaction? Photoprocess or photochemical reaction. So friends, we are discussing about photochemistry. Therefore, these reactions always takes place in presence of light. So such reactions are called photochemical reactions. So this means the chemical reactions which are taking place in presence of light, those are called photochemical reactions. These are two types: photophysical process, or you can say change. Photophysical process or change. Second one, photochemical process or reaction. The first one is changes, that means solid can convert into liquid, liquid can convert into vapor. So that is called physical change. Chemical reaction or chemical process is nothing but one compound convert into another chemical substance. So here the example is photosynthesis. Photosynthesis, you know that carbon dioxide and water react with each other in presence of light by using chlorophyll. The product is a carbohydrate, here obviously glucose. So this reaction takes place in presence of light. So this is the example of photochemical reaction. So friends, in our syllabus we have photochemistry of alkenes. So friends, when you see for alkenes, so the triplet energy, so triplet state energy always less than singlet state energy. That means what? So energy of triplet state is less than the energy of singlet excited state. So even though here ISC process is not possible for alkenes. So ISC process not possible for alkenes. So here if you want to convert the alkenes into triplet excited state, you have to use a triplet sensitizer. So right, so you can see here, right, this is the diagram, we can easily understand here. So here this is the molecule. When you do the direct irradiation, so we are going to get singlet excited state. So the two electrons are opposite direction. So the total spin is equal to 0, multiplicity 2s plus 1 is equal to 0. Yes, here. So two electrons are having opposite sign. So therefore the total spin is equal to spin of this electron. So the spin of that electron is yes plus 1 by 2 plus, and the spin of this electron, so that is opposite direction, minus 1 by 2. So this is equal to 0. The total spin is equal to 0. Spin multiplicity, yes, multiplicity is equal to, the formula is 2s plus 1. So here 2 into the total spin is equal to 0 plus 1. 2 into 0, 0 plus 1 is equal to 1. Therefore, this excited state is called singlet excited state. So here you can observe, so this is called triplet excited state. Which state? Triplet excited state. Here the triplet excited state is present below the singlet excited state, means this has low energy. Even though, so the alkene cannot directly convert so into triplet state. So if you want to convert to triplet state, so this has to undergoes the process is called ISC, inter-system crossing. So this cannot be done by using alkenes. So why we are saying this is triplet state? Here you can see the total spin, yes, the total spin for this, it is equal to plus of, the next one is also having the same direction, therefore we are taking again, so it is a plus 1. Total 1 by 2 plus 1 by 2 is equal to 1. So now multiplicity is equal to, yes, multiplicity is equal to 2 into, yes, total spin is equal to 1, so plus 1. So 2 into 1 is equal to 2, 2 plus 1 is equal to 3. So therefore we are saying this is a triplet excited state. You can observe for singlet excited state the two electrons having opposite spin. For triplet excited state the two electrons having same spin. Okay. So friends, right here when you do the direct irradiation, so this is going to produce pi to pi star singlet transitions. So direct irradiation, so it is going to produce pi to pi star singlet excited state. So when you do the irradiation in presence of triplet sensitizer, it is going to produce pi to pi star, yes, triplet transitions. That means you have to irradiate with triplet sensitizer. So then, so it is going to form triplet excited state or triplet transition state. So based on this, there is 5 kinds of reactions are possible for alkenes. So the photochemical reactions for alkenes are 5 types. Those are cis-trans isomerism, photocyclodimerization, next intramolecular closed reaction, nothing but electrocyclizations, next photocycloadditions, finally simple addition reactions. So friends, this is about introduction of photochemistry of alkenes. So in our syllabus we have cis-trans isomerism. So here friends, generally when you take the alkenes, so when you take alkenes, so this is called olefin or alkene. So you see here I am taking R group here, here I am taking R group and H. So here this is called cis molecule. What is this molecule? This is called cis olefin. So under ground state means if you heat this compound even to higher temperature, it cannot convert into trans isomer. So cis olefin cannot convert into trans isomer. That means under ground state the cis-trans isomerism not possible. So thermally it is not possible. So but photochemically the cis molecule can convert into trans molecule. So cis can be converted into trans molecule. So how it is taking place? How the cis molecule converting into trans? how the trans molecule converting into cis under photochemical condition. So friends, in this case the alkene undergoes excited state. So in this excited state the two sp2 carbons are twisted. So those are going to be twisted by 90 degrees. So now this state is called perpendicular state or photostationary state. So sometimes in exam they are asking about p state or perpendicular state or photostationary state, all are same. What is photostationary state? During the isomerization of alkene, so it is in the excited state the two carbons, which carbons? sp2 hybridized carbons twisted to 90 degrees, then that state is called perpendicular state. So what happens when two carbons are twisted? So their energy, that perpendicular state energy is going to be minimized, so reduced. So that may be in singlet state or triplet excited state. So now cis trans isomerism is disappears in the excitation. So finally it can be dropped back into the initial form. If you start with the cis, then it can be back into the cis, or it can be converted into its isomer, that means trans. So friends, this is about cis trans isomerism introduction. For example, I am taking stilbene. So you see cis stilbene under photochemical condition, when you irradiate with light, this is converting into trans stilbene. So you see the example. So cis stilbene or trans stilbene, this is the simple stilbene molecule. It is on irradiation. It is, so after irradiation, so you see cis stilbene present in 93%, trans stilbene is present in 7%. You can start with cis isomer, 100% cis isomer. So 100% cis isomer. After photochemical irradiation, we will get 93% cis stilbene, 7% trans stilbene, means this reaction has taken place. Even if you start with 100% of trans isomer, after irradiation, so we are going to have cis isomer in 93%, trans isomer in 7%. So right friends, this is about cis stilbene. How it is taking place? You see, so this is the cis molecule. I am starting with the cis molecule. So when you do the irradiation, this is undergoing excitation. What is that? So when you do the irradiation with light, this is undergoing excitation. In excitation, yes, excitation. So in excitation, what is happening, friends? So the two carbons, these are the sp2 hybridized carbons, the two carbons are twisted. You see, so this is present vertically, where this is present horizontally. What is happened? So these two are in perpendicular to each other. So this is twisted. So this part is twisted. Now, so during the twisting, the above bond, below bonds are coming within the plane. So you can observe here. So actually it is present vertically. During the twisting, it is converting into horizontally. So this is called P state. In this P state, the energy has minimized. The energy will be minimized. Now it can be converted into again cis isomer, or it can also convert into trans isomer. So that's why after irradiation of stilbene, so we are going to have two isomeric stilbenes, trans stilbene, cis stilbene. Trans stilbene present in, yes, 93% after irradiation, cis stilbene present in, trans stilbene present in 7%, yes, cis stilbene present in 93%. So let's see direct irradiation. So direct irradiation, cis trans isomerism. In this case, what is taking place? Pi to pi star singlet excited state is going to be formed. Let's see. I am starting with olefin. When you irradiate with light, so this is going to form vertically singlet excited state. What is this? Vertically singlet excited state means, so here the bonds are existed like this only, vertically singlet excited state. So this is called vertically singlet excited state. So after this it is relaxed by twisting. So relaxed by 90 degrees twisting. So that means this part will be twisted. So when you do the twisting, yes, now it is going to form like this. Yes, the electron, one electron is right like this, another electron is like this. So now right here. So when you do the twisting, so this is undergoing relaxation, that is called non-vertical singlet excited state. Non-vertical singlet excited state. So there the same reaction can also start with the trans-olefin. So irradiation going to form vertically singlet excited state. So the same thing. So the bond S, these are the p orbitals. Singlet excited state means one electron having positive spin, another has a negative spin. So again it is relaxed by 90 degrees twisting, so forms non-vertical singlet excited state. So friends, non-vertical singlet excited state relaxed and partitioned into cis-trans isomer. That means, so if you start with cis olefin, this non-vertical singlet excited state relaxed to cis isomer or can convert into trans isomer. If you start with the trans isomer, the non-vertical singlet excited state convert into cis olefin or trans olefin. The same thing we are going to explain by using the molecule. Here I am starting with the cis molecule. You see, on irradiation, yes, it is going to form, yes, right, theta is equal to 0. So the angle is equal to 0. This is called non-vertical singlet, vertical singlet excited state. So exactly vertically is present. Therefore it is vertical singlet excited state. Now it is relaxed by 90 degrees CC rotation. So this is rotating by 90 degrees. So now you see right here we are going to get, yes, so the twisting. So when you twist this, here the theta is equal to 90 degrees. So now this is called non-vertical singlet excited state. Non-vertical singlet excited state. Here electron repulsions are decreased because the two electrons are adjacent to each other. Here one electron present at this position, another electron present, so horizontal plane. One is present in vertical plane. So the same thing you can explain by using trans isomer. Trans isomer is first irradiation, convert into, yes, you can observe here friends, this is a vertical singlet excited state. Here the compound is having theta is equal to 180 degrees or are opposite to each other. So here this is vertical excited state, singlet excited state. It is relaxed by CC bond rotation by 90 degrees. So we get non-vertical singlet excited state. So friends, here it is relaxed and partitioned into cis and trans isomer. That means this P state, this is called P state. What is this? Non-vertical excited state is called P state. This P state can convert into cis molecule or trans molecule. Even if you start with the cis, this can convert into cis molecule and also trans molecule. So friends, this is a direct irradiation cis-trans isomerization. So next, triplet sensitizer irradiation. So in this case, the excited state is pi to pi star triplet excited state. Pi to pi star triplet excited state. So friends, so generally alkenes cannot undergo ISC process. They are inefficient for ISC process. If you want to get a triplet excited state, you have to use triplet sensitizer. What we have to use? Triplet sensitizer. How we are using sensitizer? So first you have to take the sensitizer, irradiation, convert into singlet excited state. The sensitizer undergoes singlet excited state. So now this sensitizer undergoes ISC process. So during intersystem crossing, singlet excited state converting into triplet excited state. So here if you use alkene, so now these two will be collide with each other. That means this is going to collide with alkene, then these will interchange their energy levels. That means so sensitizer undergoes ground state level, and now alkene undergoes a triplet excited state. So for example, so acetone, benzophenone, so are the best examples for triplet sensitizer. This is the triplet sensitizer. Irradiation, first it forms a singlet excited state, ISC process convert into triplet excited state. Here we used the stilbene, that may be cis or trans. You can use cis stilbene or trans stilbene. So after irradiation of benzophenone, it is converting into singlet excited state. The benzophenone only undergoing ISC converted into triplet excited state. Here we are adding stilbene. Now stilbene collide with the triplet excited benzophenone. So now these are interchanged their energy. Now yes, you can observe here, stilbene undergoes a triplet excited state where benzophenone comes under ground state level, S0 level. So now this stilbene undergoes cis trans isomerization. Here cis stilbene present in 93%, trans stilbene present in S7%. So friends, here let's see the triplet sensitization, cis trans isomerization. So friends, this is I am starting with the cis molecule. So it is on irradiation with the triplet sensitizer. Now we are going to get, yes, so this is, you can observe the two electrons having same spin. Here theta is equal to 0. So this is vertical excited state, and you can here you see, so we are using triplet sensitizer, we got a triplet excited state. So this is a vertical triplet excited state. Now this is relaxed by 90 degrees cc bond rotation. So now it is going to form So after rotation, so this part will be rotated. So now we are going to have this is non-vertical because it is existed like this, and this is existed horizontally. So now this is called non-vertical excited state. Here theta is equal to 90 degrees. Here electron repulsions are decreased because I already told you friends. So the same thing you can start with a trans isomer. Trans isomer triplet sensitization. So convert into excited state. Yes, which excited state? Triplet excited state. So this is relaxed by cc bond rotation. We get non-vertical triplet excited state. So now it is relaxed and partitioned. That means this is called P state. This is called a P state. Nothing but what? Perpendicular state or photostationary state. This P state can goes back to its original form. That maybe you start with cis, it can convert into cis, or if you start with a trans, it can convert into trans, and also it convert into its isomeric form trans. So friends, this P state convert into cis isomer and also trans isomer. That means after irradiation, so in the final product we are going to have cis and trans olefins. So friends, let's see the energy profile diagram. So here this is the energy. Here we are taking theta is equal to 0, theta is equal to 90, theta is equal to 180. So theta is equal to 0 means cis molecule. cis molecule on direct irradiation, we are going to get vertically singlet excited state. This vertically singlet excited state so undergoes relaxation by rotation around 90 degrees, forms yes non-vertical singlet excited state. This non-vertical singlet excited state can come back to yes cis molecule, original molecule, or can converting into yes it is a isomer trans molecule. So here this is called P state. What is this? It is called a P state. Yes. The same thing. So when you use the triplet sensitizer, so we are going to get yes the two electrons have same spin. So that's why it is called vertical excited state. Vertical triplet excited state. This can be undergoes relaxation by 90 degrees rotation, forms non-vertical triplet excited state, or you can say P state. Now this can come back to the cis form or can converting into the trans isomer. So if you start the reaction with the trans isomer, yes, so first it forms by triplet sensitization by using irradiation with the triplet sensitizer. It is undergoes vertical triplet excited state. It can come back to the non-vertical triplet excited state. So now this P state convert into the cis form and trans form. If you do the direct irradiation, it forms vertically singlet excited state. You can observe here. So this is undergoes relaxation by 90 degrees rotation. It forms non-vertical singlet excited state. This non-vertical singlet excited state can convert into the cis form or can come back to the trans form. So friends, this is about cis trans isomerization, photochemical cis trans isomerization. So friends, we will meet in the next class. Thank you.